Previously, we've created our VPC. We have also practiced some Git magic, making sure we're able to move smoothly and without any issues. And today, our next task is to create some EC2 instances and run them in our VPC. And let's dive into it immediately. It will be, I would say, significantly easier. It's just another resource that we need to create. I'll create a separate file for that and start coding. So yeah, anytime we start a new resource.
Checked out.
Sorry?
I said you've not checked out your before creating a new file. You didn't check out of main.
Yes, of course. Thank you for reminding, but don't forget to raise a hand when you have something to add, if you don't mind. Yes, we will for sure check out main as well. Very good. But what I wanted to show is where do we get information about how we're gonna code and what we're gonna code. In documentation, Terraform EC2 instance. Here is our here is what we'll use. Here is what we'll have. And yeah, let's check out main. Pull everything and create a new branch. What examples do we have? Probably this one will be good. No, that one will confuse us a little, but anyways, when you do it yourself, take your time reading through all these examples. But I will, recreate and restart it like from zero, if you don't mind, just to go in a step-by-step approach and explain everything line by line. So the resource itself is AWS instance, right? What we need to specify is AMI. AMI is like a snapshot of our virtual machine. So if we want to use Linux, we'll use one AMI. If you want to use Windows, we'll have different one, different distributions, different versions. We'll have different AMIs. Also, I will set associate public IP to true. And this will means we won't have to create an elastic IP address or associated with our instance. There will be public IP automatically for us. Instance type means what size and what configuration of our virtual machine we're gonna use. Yeah. So previously we had only probably this, very basic configuration, but right now today we'll have significantly more options, and we will also put our virtual machine into the VPC that we have created. I will provide a key name. If you already have a key that you've created, you can do by just specifying the key. Otherwise, you can go to, if you haven't yet started any instances, you can go to AWS console, to AWS portal, and create a key directly there. And let me demonstrate this to you as well. You just need to go to EC2, key pairs, and press create a key pair. you'll specify the name. This one, if you use Windows, you need to choose PPK. If you use Mac or Linux, you need to use PEM. Create a key pair. It will create it over here. You can specify it using this name. And this one is your private key. You'll use it in your SSH client. So I'll delete this key for now. We don't need them. I will use my primary one, which is called main. Also, each instance requires a security group. A security group is a firewall rule, which describes which ports, which protocols from which IP addresses are allowed to establish network connections. And I will create security group later down the road. And also, what we need to have is our subnet ID. Basically, this means VPC and to which subnet we are going to put this instance. And we need to choose one of our public subnets. This means AWS subnet, public, dot public, at our index, for example, 0.id. And there was a raised hand. Someone has a question. Yeah, nice question. We can create a key pair using Terraform, and if you would like to do this, you can do this as an extra mile, I would say. But in general, it is acceptable if we create it manually as well. So, but it's anyways up to you. Yeah, and overall, yes, you can. Okay, let's move forward for now, and I will leave some time for questions a little later as well. We should never forget adding tags, especially the name tag. Same way we did day before yesterday. There will be environment code variable that we reference, and some unique identifier. So we distinguish that that's our public instance. Now let's move forward and create the security group. So I will have a unique name that also contains our environment code. It also requires a description. And let's put the security group into our VPC. You might see the task related to code style. And one of the most important things in code style, especially in Terraform, is to make sure your arguments are aligned. So this one is bad, this one is good. But you don't have to enter type in a lot of spaces all the time and spend your time. Instead, what you always can do is save the file, go run Terraform fmt, and it will format these and change this formatting automatically for us. So never forget to run this command. Very, very useful, very important, and it makes your code looks much more prettier and the result of your work much more professional. In our security group, we need to define what rules should we have. So similar to what we've created in our user interface. Yeah, so in security groups, we go here here this wizard, right? So SSH from this IP, from that IP, and so on. Same thing we should repeat in our Terraform configuration. So this will be ingress. So we need SSH first of all, so we can connect to it. This means port is 22. So why this from port and to port? What they mean? Actually, we can open ranges, port ranges. This means if we specify, for example, from port 22 to port 80, essentially this will mean all ports from 22 to 80. So if both from port and to port equal to 22, this essentially means that only port 22. So protocol is TCP, and CIDR blocks equal to my public IP. And how do we find out the public IP? Let me show you. So the delay? Yeah. To find out your IP, you can just go to Google and type my public IP IPv4. And first result from this search will give you your public IP. So this one is 37.19.06.557. So that's don't be confused and don't run ipconfig and don't type your local home network IP, right? It should be global one, and you can only find out it through this website. Let's take it. We also need to add /32 because it operates using CIDR ranges. And what /32 means, like smallest range, which essentially means only this IP. So every time you need to limit something to your IP only, you need to find out your IP using this website or any similar websites. After that, copy it and append also /32, at least when you use it in this ingress security group rule. Also, we will need to talk with the internet from within our instance. This means we need to allow everything outside, egress. In order to allow all traffic, we need to specify from port and to port 0 and protocol -1. And CIDR blocks mean have 0.0.0.0/0. This means any IPv4 address within any range over the internet. And also don't forget to align everything carefully. You can do this either manually by specifying some white spaces here, or just run Terraform FMT. Very good, very cool. So we have our specification for, basically that's the same that we've created on our second task when we were verifying our network using EC2 instances. Yeah, that's exactly the same representation of what we've created manually on Tuesday, on Wednesday. Okay, no, doesn't matter, never mind. Now let's go ahead, run Terraform apply. It doesn't have env code. Why? Seems like something didn't went well when we did pull. And this is actually very good. I can demonstrate rebase in action in so-called organic, in organic settings. Let me commit everything first. What I did, what happened? It said it's unable to decide which version of the change it should prioritize. It asked our input. What I did is I resolved all conflicts. Now I need to run git add and git rebase -- continue. Save it. It says successfully rebased. We can git push -- force. Let's see that, yeah, now we have variables tf and these Terraform tf vars. Let's run Terraform apply one again. And sorry, I'm not always good at typing English words. Couple more minor mistakes. And also for some reason, it does not like this, AWS subnet public. Let's see what we have. AWS subnet, public, AWS subnet, public. Interesting. It's supposed to work well. Okay. It says inappropriate argument, subnet ID string required. And also I forgot to paste security group IDs here. So string required, and this time here we have a list, so probably it should be like this. This means it will be like just string. And VPC security group IDs, yeah, of course, it should not be empty. AWS security group public, that's the one. And this one, if I remember this correctly, hopefully it will not give us next mistake. It requires a list, means this value is a single string, like this one. And when we enclose it into square brackets, this means we created a list of it, and this means we can pass, I would say, multiple values into a single property. Let's try one more time. Finally. We'll allow these to run, and while it's running, we have probably like 3 to 5 minutes to have our VPC created. We can use this time to discuss and answer these questions. Yes, Ramraj.
Hey, Vladimir. So this is regarding Git. I was able to rebase with main, my variables branch.
Mhm.
But even after that, when I'm trying to commit, it was throwing the error. I saw that you used dash force option. Is that how you are supposed to do it?
Did you get an error when you did a rebase and were trying to push?
Yeah, so I got since my branch was 4 commits ahead of main, I got 4 exceptions while I was doing rebase, and I was able to correct those changes by going into VS Code and accepting those changes, and then finally I was able to rebase my variables branch with main. But I was not able to push the current changes in variable branch to commit and then I was able to commit but not able to raise a PR. I was still getting conflict.
Yeah. You need to use force every time you use rebase. Doesn't matter if you rebase from a different branch or do interactive rebase. You need to use force because rebase is like rewriting your commit history.
Oh, okay.
And without force, pushing only possible if you append something to existing commit history. But when you wipe it out and rewrite it completely, it should be like forcibly overwritten.
Okay, cool. I did not use that, and I gave up. I wanted to move on, so I created another branch called variable, and I just moved on with it. But I can try to recreate something with smaller change and try to do it. But at least I definitely learned a lot about rebasing and how to resolve it. So that was very helpful.
Yeah, so as long as you don't recreate the entire repository, it is okay to experiment. And I wouldn't expect that I demonstrate rebase once and everyone immediately grasps it and understands, right? So
Yeah,
it is fine. Yeah.
So, can you go back to your VS Code? I have one more question with the current changes that you're doing. So you were able to call the subnet ID by just calling the class and the attribute ID, versus some of the in tags you were able to do like variable.env code, right? So Terraform, like all the Terraform files, Terraform treats them as like a repository and be able to pull it from any file by just calling the class name and the particular attribute.
Yes. So the entire folder is our workspace. The entire all variables, all resources are namespace to a single folder. So you can define any file. I can create how I did here. I created VPC in this file, and I automatically can connect within a different file.
Oh,
So-
okay, that's great. It's not
Yeah.
like Terraform where you have to import it. It's just available in any file.
Yeah, it's just available, and later we will. So we will reorganize and split everything, and there will be, I would say, advanced tactics about how we limit the scope of a variable.
Okay.
But
thank
by
you.
default, it's a shared namespace.
Okay, thank you.
Okay, so one more question in the chat, Abnina. Do we need to use argument associate public IP address if we already made use of map public IP on launch in the public subnet resource? Do they both do the same thing? Yeah, good question. And as far as I remember, yes. If you have map public IP on launch, you don't have to associate public IP. Essentially, yeah, that's the same thing. And Sanjeev, I see your raised hand. What question you have?
Yeah, so this resource, right, that you defined the VPC security group ID, right?
Okay, yeah, this one, right?
Yeah,
This one.
yeah. So I mean, generally thinking of the high level picture, right? So we have before lesson you actually went over and created a security group ID, security group called public, right?
Mm-hmm.
And then we said, okay, that is the only security group, or I mean, generally, if I have multiple security groups, it's a list, right? So I was kind of thinking, what is the use case generally when we have multiple security groups?
There are many use cases. For example, we might have a public instance that should be available from our public IP, and also that should be able to talk with private instances. So perhaps you'll have AWS security group public, and also AWS security group private, something like that. Basically, like by purpose, like assigning multiple interfaces to an instance. So same
To the
here.
NIC card. Okay, got it.
Yeah.
Okay. Thank you.
Okay, yeah. Our resource is created. Let's move forward and try it out. So I'll go to EC2. And where is my instance? That's very interesting. In which region am I? 1 second. US East 1. Yeah, here it is, this one. It has a public IP, and we can connect to it. I will start my SSH agent. I will add my key to the agent, and I will SSH. User at. Here we are inside this EC2 instance. Now let's repeat the same and create a private instance. Give me just a second, sorry for that. So essentially, it will be very similar. So we'll have AWS instance. I just copy paste from here. Let's call it private. Same AMI. Security group will be private, and I'll create it in a second. Subnet ID private. We don't need to associate public IP address. And also, let's create a security group. And instead of public IP, the rule will be to SSH from entire VPC. And what we can do is reuse the variable which stores the CIDR range of our VPC. This means if an instance is within the VPC, it can connect to here. Egress remains the same and we'll change the name. And let's run Terraform apply. Okay, so we can go and check our instances. Here is the one. The second IP is 100.125. And let's SSH to everywhere to make sure that everything works fine. I've SSH to my public instance. Now from this public instance, I am SSHing through another hop to the private instance. And it is working fine. Very good. Let me run Terraform destroy, but we're not done yet for today. We'll have something else to show. And while it is destroying, let's git push and create a pull request. And while it is destroying, we still have a minute or two to discuss questions. And yeah, let me know if you have anything. No questions so far? Very good. Cool. So the next step for us is to let's say we want to try deploying this in a separate region. And we kind of had similar case here. So let's say we want to deploy it to US West 2, right? And when I run Terraform apply, you can tell me what will happen. Okay, first it gave us error that availability zones are not right. Yeah, so this means every time we need to switch a region, we need to change the availability zone. Let's do this. Okay. And yeah, I wait. Yeah, it should be West as well. Yes, Piyush.
I have a quick question on that instances creation. Why we have not used the count.index?
Good
At
question. We can do this. Yes, why not? It's a very good opportunity to use count index as well. But like, if you would like, you can move just beyond and yeah, also use count index there. But make sure you don't just create 2 instances in the same subnet. Use different ones.
So in this situation, it will be only one instance because we have used 0.
No, we will use do you mean instead of defining instances 2 times, public and private, we will use count
No,
index?
not that one. No, not that one. Just the index position was 0, so I just wanted to know whether we can use that count.
There is no count in our instance. Count, this means we don't have count index. So count index means on whatever iteration you are, take index of this iteration. And it will only be available when we have count. If we only if we have only one resource, we have nothing to count simply.
Correct. Okay. Oh, sure. Thanks.
Yes, Sanjeev.
Hey Vladimir, so you change the region, right? So so is that like if you're in your home region or if you want to define that, we can
Yes.
we define that in a variables.tf, right?
Yes.
Can we define that and then make it dynamic?
In provider.tf. Yes.
Yeah, in provider.tf, but can we make it dynamic in the code?
In provider.tf, no. So let me show you. This place, no.
Okay.
At least from the variable. This place, yes. And that's what I'm going to show you actually. So let me first, I should have pulled it. 1 second, reset minus hard. Pull origin main. Yeah, now Let me real quick reset this one more time. So this will be US West.2, and this will be West2, West2, West2. And now we have our instance. So when we run Terraform apply again, it should have given us an instance. Let's hit yes, and we will see the error, the one that we should expect now. It says invalid AMI ID not found. Image ID does not exist. Who can tell me what might be the reason? Yes, I see a lot of hands, and I didn't catch who went first. Ritika.
Yeah, the image ID is not specific to that region.
Yeah, very good. Exactly. Same as we had before. And previously, the solution was to simply go, find out which image ID we have, copy, paste, repeat, restart, and it is obviously not flexible. It is not how we're supposed to work long term, right? We should not copy. We should copy paste a small amount as possible. So, and in this case, to our rescue comes the thing called data source. And this is what we're going to do next. We're going to configure a data source. And what is data source? Data source is, I'd say, a query to the cloud provider. Using this query, we can say, whatever region you are, give me the latest AMI, the latest AMI ID of this, for example, Ubuntu Linux or Amazon Linux operating system. And let me show it, and it will be even more easier to understand. So in our instance TF, we'll have the following construct: data, AWS AMI, and we're using Amazon Linux, let it be Amazon Linux. And a couple of parameters. We'll say that we'll have the most recent AMI, because every time there is an operating system update, they're releasing new version of the AMI. And we'll provide some filters. And using filters, we'll basically limit what criteria that the Terraform should use when searching this AMI. So we'll query by name, and the value will be the name of our AMI. That's amzn2 -ami -kernel whatever goes next. And also we'll use another filter. We'll filter by virtualization type. Which stands for HVM. And don't forget to align things properly. What we can do next is, instead of hardcoding this AMI, we can say data.aws AMI Amazon Linux.id. Similar to how we reference subnets, we can reference something that wasn't declared by Terraform itself, that lives outside. And we can also repeat this for our private instance. And from now, we can, okay, first of all, run Terraform apply, and it will read the proper AMI. It should be values. Read the proper AMI automatically without us having type it, and obviously doesn't matter which region we choose, it will have this AMI created. And referring back to the previous question, we can not only use AMI ID. We can not only obtain AMI ID using data source. We can also we can obtain like almost anything, almost any information, right? For example, yeah, once again, availability zone data source exists. And that, yeah, we see that our instance is now created in this new region. And let's also declare some data sources for our availability zones. Data AWS availability zones available. This one we no longer need. And instead of referring these locals, we can use this data source. It's this data, AWS availability zones available, names at count.index, since we're using count here. And same for our private. Let's try this. Zero changed means it corresponds to what we've done. So when we're creating some infrastructure improvement, it's a very good measure. Yeah, we refactor our code, we're starting to use different functions, different constructions, and if the actual infrastructure has not changed, this means we've successfully updated and created everything. And with that, let me real quick go through the remaining questions. While I was creating public and private subnets, we gave the value for AZ US East 1A and 1B, and I got this error. Creating EC2 subnet and valid parameter. Okay, so you are creating US East 1 availability zone in the region US East 2. Your availability zones should be US East 2, not 1. That was the mistake, Samira. And if you're still getting this mistake, just afterwards, this error, just afterwards, send us a message in Slack. We'll assist you. Yeah, and this is what you said, by the way, later in the same message. Yeah, very cool. Sanjeev, you have a question, right?
Yeah. So you said we can use the data source to get the dynamically, right? Send a query to the by API and call and get the filter condition, get the dynamically get the information. So you can extend it to region also, right? I mean, my question is, when you define a provider, do we have to operate in the same region? Is it the expectation in general, or is there a concept like home region and then for the provider, and you can actually cross region, you can create resources?
You can a single provider operates in a single cloud in a single region.
Got it. Okay.
But you can create multiple providers. For example, provider AWS, region, let's say US East 1, and we'll also need to give it an alias. Something like that. You can define unlimited number of providers. even multiple clouds, even multiple technologies, not only cloud. But single provider lives within a single cloud provider plus region. That's why it is called provider. It represents this entity of essentially provider.
So like you said, if you want to create a cross region, then you have to use that region's provider and that's a starting point. And from there
if you want to run cross region, you need to create two providers that represent your first region and your second region.
Got it. Okay. So in the code, you will use the alias in the resource notation somewhere to reference to the provider, or
yes.
Okay.
Git commit. Yeah, let's commit everything. Use data sources. Let's push and create a pull request. Double check, make sure everything is fine. And merge. Also, when we finish working, don't forget to run Terraform destroy. And yeah, so for today we are done. Thank you, guys. This was very outstanding and productive week. I really enjoyed meeting you all. Looking forward to Monday. Have a great weekend. As usual, I'll stick around in case you have questions. Otherwise, bye-bye and thank you.
Thank you.
Thank you.